Hi, this is Jay Prakash, and I would like to share some of my work. I experimented with convolutional neural network. In this video tutorial, we'll experiment with one of the most popular algorithm called convolutional neural network, which is used in the field of image recognition and image classification. So let us understand what is a convolutional neural network. But wait, before understanding CNN, let's understand how the human brain works. So, more precisely, how do we recognize the objects, images, and the people around us? Understanding this is the large part of understanding the convolutional neural networks. In a nutshell, our brains depend on detecting features and they recognize the objects we see accordingly. You have probably been through hundreds of situations in your life where you looked at something instantaneously, made it out to be something, and then after looking at it more thoroughly, you realize that it is actually something completely different. What happens there is that your brain detects the object for the first time, but because the look was very brief, your brain does not get to process enough of the object's features so as to categorize it correctly. Let's start with the brief game of optical illusions. So let us look at the following images, right? So this is one of an image. So what do you see here? You can see there is a man's eyes over here, and there is a nose, and there is a big mustache. But if you see in the other angle, there is some hut over there on couple of sides, and there is a kind of a tree branch, and there is a boy sitting over there. So this is an optical illusion where your brain at the first instance it tried to perceive there is an old man, but when you come back and look, it is not. You have some other perception to the same. So let's go to the other image and see here. So there is a man, and in one angle when you see he is actually he's been standing and he's looking at something, but on the other hand, if you see it has been a lake or whatever. So this is kind of an optical illusion again. Let's look at one more example. So you can see like in one way you can see a man's face, but on the other angle when you see there is old lady walking towards something. So why we are playing all these games? So let's actually stop here and the point to be made here is that your brain classifies objects in an image based on the features that it detects first. All these images were designed so that what you will see in them depends on the line and the angle that your brain decides to begin its feature detection first. As we proceed in our section on convolutional neural networks, you will realize staggering degree of similarity between how these networks operate and how your brain does. Just like your brain oftentimes mistakenly categorizes objects at first, convolutional neural networks are prone to the same indecisive problem when presented with an object or an image from an angle that can be easily place it under more than one category. So why convolutional neural networks are so important? Let's understand some real-time use cases like how do the self-driving cars, something like a Google car or your whatever, right, recognize other cars as well as pedestrians and other street objects? How is it able to drive without a driver? How did Facebook go from making you tag people in images yourself and to be being able to identify your friends and automatically tag them as it does now? So answer to both the questions to be short and sweet. It's a magic of convolutional neural network and it is abbreviated as CNN. So the first thing you should be able to understand what is convolutional neural network is at a very, at 1 lakh feet above. Convolutional neural network is nothing but an algorithm where you feed some training images, historical lot of images. It creates a hypothesis and it segregates your images into multiple classes. And when you have a new image coming in, when you try to predict it, it falls under one of the n number of classes. So this is what at a 1 lakh feet above or 1 million feet above when you look at a top view. This is what it is, but we will definitely deep dive in the next sections. But for the first introduction, for the first time when I want to show you, so this is at a high level. There is an hypothesis in the middle, and it is being trained and some with some historical data, and then when you get a new data, it automatically classifies. So some advanced use case of a convolution neural network can be like it can be used to detect human emotions in an image. For example, when you feed in a lot of images with various emotions, and when you train it, it can fall under multiple categories like smiling. I mean, he's happy, he's sad, he's upset. What else? I mean, so various human emotions, right? So that is one of a very advanced use cases it can be. But achieving is sometime, it needs a lot of advanced level of training, since being able to infer someone's emotions from their facial expressions is often a very puzzling task. So before getting into the details of this operation, you should first keep in mind that the way the black and white images are scanned by this algorithm differs in one major way from how the colored images are being scanned. So this is how your CNN scans the images. So when your CNN captures a black and white image, it is converted into a 2D array. And when it is a colored image, it is converted into a 3-dimensional array. When actually the 2-dimensional array, it is going to be between your black and white. But if it is a 3-dimensional, when it is a colored image, it is falling under a 3-dimensional array, and it is going to fall under red, green, and blue spectrum. So let's go to the next slides. So convolutional neural network considers an image into multiple pixels, and each pixel is 1 byte, and 1 byte is 8 bits. So that we have 256, that is nothing but 2 to the power of 8, which is 256 numbers. And for black and white, it is like only a 2-dimensional array. So it is 0 is black and 255 is white, and everything falls under that is going to be like gray. But in case of a colored images, if that pixel, if it need to be like, if you want to detect as pink, it has to be falling under the spectrum of red, green, and blue, and each is having a value. So this is how the convolutional neural network detects a black and white image and a colored image. And this is like my first video on this video series, and this is like I feel like I gave some pretty decent introduction for it, and we can deep dive and get into very, very specific, very, very technical on this convolutional neural network from the next videos. Thank you so much.